Hi, I'm Tom and I talk about code. Welcome back to my PlayStation 2 homebrew development live streams. It's been a little while, okay? Easter got a bit messy, stuff was happening. I came back, I went back to Adelaide for some family stuff. So, we're gonna be showing off some of the work that I've done over the last few weeks, right? Because I haven't just been, sitting around doing nothing. I've still made a couple of really fun improvements to this engine off stream. We're going to come in today, we're going to tackle player movement, we're going to make this a lot more fun to play. But first things first, let's show off where this is now. It's looking a little bit different, it's looking a little bit nicer. Okay, so we've got some kind of, procedurally generated planets in the background. We can move around, we can shoot things. I don't think it quite looked like this last time I showed it off. Maybe it did, maybe I'm not remembering quite right. But, we have this kind of random star field, we've got a player that moves around. This is pretty exciting, there's a lot going on here. The random stars in the background, a lot of love and care went into each of these stars, okay? It's randomly generated every time the game starts, so are the arrangement of planets, which is why some of these guys overlap a little. We'll fix that later. We'll do a better RNG for this, but the star field is actually cool. These stars will flicker just a tiny little bit. Just a little, right? Just enough to make it feel a little bit more alive, a little bit more dynamic. Now, behind the scenes, this is looking like a completely different engine. So let's have a quick look at this source folder. For one thing, we now compile our own version of Lua that we build against, right? This means that I can apply certain compiler flags, and it seems to have fixed one of the biggest classes of crash, which is amazing, okay? I was having lots of Lua issues. It seems like some of those are now resolved. I'm just gonna... Oh, this microphone stand is brand new. I have just set it up then. So let me know throughout this stream how I sound. It's going to be a little bit different than usual. So we're now building our own Lua, and we now have our own kind of Lua patch that we apply over Lua for a whole variety of reasons that aren't very interesting. Check out the closed PRs on the repository if you want to know more. Cool. So if we look in the source, okay, there's an interesting folder here called Linux. Linux allows me to build this engine to run on a Linux computer. But it doesn't build the entire game, right? I can't run the game on Linux. I was experiencing memory corruption issues, right, when I was trying to play around with a couple of things. And so I wrote a stubbed out. Let's have a look at what one of these Linux files actually looks like, right? So let's go to vgraphics.c. So these are PS2 SDK functions, and they do nothing. They just exist. And they just exist enough so that I can compile the program and run it. And so what I've written basically is a stubbed PS2 SDK environment. I can compile against that on a Linux machine enough that, some of my memory corruption bugs are actually reproducible on Linux. I can run the binary in Valgrind and GDB, and I can identify these things. So this, I'm not trying to make my game cross-platform. That's a disgusting amount of work. But for now, I'm going to tackle PS2 SDK stubs so that I can actually just compile cross-platform to solve certain classes of issues very easily. This is all very cool. Again, check out the closed PRs on the repo if you want to see how this works. And behind the scenes, I did a few other things. If I go into engine script, I now have a hot reload function. So I can reload modules, and there's just a bit of like Lua messing around to make this happen. It really isn't that complicated, but we're going to use that today, and we're going to try and iterate very, very quickly on player movement. So I'm just going to do a quick little bit of setup, and then we are going to start playing around with this, because let's have a look at the problem we're trying to solve today, okay? When I move the player around, right, he comes over here, and I take my finger off the analog stick, and he mostly stops. Sometimes there's a bit of stick drift, because this is an old controller, but I come down over here and I stop. I come over here and I stop. And that's not how space works, right? In space, you're supposed to keep going forever. So we're going to tackle player movement. We're going to tackle it in 3 steps. We're going to tackle momentum. We're going to tackle acceleration, how we actually build that momentum in a more realistic and satisfying way. And then maybe we're going to do some friction. We might have some slowdown eventually, so you don't just, fly off forever. That may feel better. That may feel worse. But either way, we're going to make it something we can configure and play with. Let me just pop out chat real quick. Who have we got here? Amir HD 124, hello, welcome. And Seta Siggy, cool to catch me live. Thank you very much. It's cool to have you here live. All right. Let's just quickly do this. Perfect. Sure. Sure. Where did... I lost it. I lost it. Okay. We're good. We're good. Okay. So just the important thing I'm trying to check here, just quickly off camera, is that I'm using the most recent engine version, and I appear to be with this branch already, which is good. So, cool. I've got a player movement branch. Okay. I've done this all before. Just quickly, I'm going to make one change that I think I lost in this branch, and that is scripts. My scripts rule in the make file, it also needs to run make scripts in the actual engine. This is just to do with hot reloading, and this is just a small technical thing that doesn't really matter. Should have done it as setup before, but here we are. So, let's run the game, right? Let's just run it. I'm gonna do that over here. Okay. So we're running the game. Let's see if we can make a change to the player while this is running. Well, we probably can't, right? Because we need to actually tell the game to reload. So let's go reload. Entity.player. This should reload the player. This should work. This should be what we need to get this started. Sounds pretty cool. Sounds pretty cool. So let's come in, let's rerun. Okay, so if I hit select, nothing should happen, but we shouldn't well, other than toggling the debug draw stuff. So that's cool, that's cool. We're also actually going to run into an issue where our game manager is going to continue to spawn rocks, right? It runs on this timer, blah, blah, blah. It's going to spawn these rocks. We really need some kind of hard limit to how many rocks it's going to spawn. Otherwise, while we're trying to iterate, it's going to be a problem. Or we can just turn rock spawning off. And actually, let's just do that. Let's just turn off rock spawning for now. So we're going to again, run this from a different window so that we have our editor up, and let's do this. Okay, cool. So we've got our player. Let's go into our player, and let's see if we can change something while the game is running. I had to play around with this, and I was actually, doing some changes to the player while this was running on an actual PlayStation 2 the other day, which is fun. But just for ease of development, I'm not doing live PS2 work yet. I'm going to get a capture card and get that set up, but that's a little bit in the future. Okay, so if I go into player update, right, where do we move? We get a direction from the pad, okay? So we get, which direction the left analog stick is in. We scale it by some speed variable. Let's change this. Let's change this to 120, okay? So I come over here. Our player moves at this speed. I'm going to go make scripts. So that should do everything. Now if I hit select, we expect our player to go a bit faster. Okay, and that's barely perceptible, but I think it is. What if I go very, very slow? That should be more easy to see, okay? So we come in here, and we go very, very slow. So there we go, we're hot reloading code. And like I said, I actually did this live on a real PlayStation 2 the other day, which was very, very fun. Exciting to see, right? This is the kind of thing I've been building up to. This is why I chose Lua as a tool. And also all the awesome people watching right now, if you can please let me know how I sound, because this microphone arm is new. So we're kind of making it up as we go right now, as far as audio quality, right? It's like that scene in Wallace and Gromit with the train tracks. Okay. So something critical is missing from the way we model our player's data, and that is our current speed. We have the speed variable. This is like the fixed speed that we move at when we are moving. This isn't what we want. Okay, we need to have some way of tracking the player's current momentum. So we're gonna we need to be careful cannibalizing it. Let's call it momentum. I guess it's the player's velocity, right? So it's going to be a new vec2, and it's going to just be default. It's going to start at 0. The player's going to have no movement. But every frame, we're going to move the player this much. So I guess the easy thing to do here, right? The easy thing to do here would be to say, See, this is where my decomposition here starts to make less sense. Acceleration probably needs to come before momentum, or they kind of need to come together. Let's try and hack something in first, though. So let's say... Let's ignore our direction for now. We'll ignore our direction for a minute. Let's just say... we add our speed to our position, and we also add... we add our speed to our AABB's position, but we learnt before that this is problematic for a whole host of reasons. We don't actually use this AABB, so I guess that's okay. Let's just ignore the AABB for now. The player effectively does not have a bounding box in the current logic of the game. So this is good, so we face the right direction, and then we just move, right? We just move. So if I set some... So let's actually see if this crashes. I need to run make scripts. Did this blow up? It didn't. Okay, so now I can come in and I can maybe say... self.velocity equals... Let's maybe go 10 times dir, right? Well, let's go dir scale 10 times dt. And our velocity is going to be equal to... Well, our velocity x is going to be equal to dir.x, and our... There are better ways to do assignment, but we'll wear it like this for now. Velocity. Velocity, okay. So if we come back over to our game that's running, we hit select. Nothing happens. This may be an error. Doesn't look like it's an error. Yeah, no, I can still shoot. Okay. Why aren't we moving? Why aren't we moving? We probably aren't moving... We probably aren't moving because we've introduced a new field. Anytime you introduce a new field, this system kind of breaks, right? So now we're using a velocity to track our movement, right? The problem is we're scaling it based on this direction, and this direction is just the raw input that comes in from the pad. So we're saying that if our analog stick is all the way over here, we set our speed all the way over here, right? But if our analog stick is here, we're setting our speed to nothing. So what we need to say is, if there's a... Let's do this simply for now. Let's say that if our direction vector, if length of analog stick is greater than some value, some x, then update. Right? Only update velocity when our analog stick has exceeded some threshold. And we can do that very, very simply. So let's say if dir length, I think it's length, is greater than 0.4. Let's make some number up. If it's bigger than this, then we update. If it's less than this, we just remember whatever our last velocity was. This is going to be a little bit janky, but it'll get the job done. And I didn't run make scripts. You guys in chat have to remind me about this, and oh boy, I'm sure people in the comments, the commenters are going to be having a field day. Okay, something crashed. Because this is not Lua syntax. How does Lua work again? That's how Lua works. Okay, there we go. There we go. It always just takes me a minute to get my Lua hat back on when I haven't been doing it for a while. Here we go. Okay. So we can set a direction, and we're just going to keep going in that direction. There we go. Right? And we can leave this running. We're just going to carry on with this velocity forever. This is the design. This is what we wanted. This is what we said would happen. Which is perfect. Which is perfect. Okay. So, momentum. Done, right? We have a velocity, we remember our velocity. The problem is this is a little bit unsophisticated, right? It feels not very good when we're going at this speed, and we've been traveling at this speed, you know, just in this loop for ages, and then we just go whoop, and now we're moving at this speed, right? We can change direction perfectly on a dime, which doesn't feel that good. Also, you'll notice we go a certain speed in this direction, right? But then as we let go, we kind of ungrab at a slightly lower speed and potentially even a slightly different angle, just because the way you let go of an analog stick isn't perfect. We've got a question in chat. What's my end goal? To make a game or to create tools for creating homebrew PS2 games, or just pure curiosity? More of the first one and the last one than the middle one. I want to make a few games. So in doing so, I'm making a framework for building PlayStation 2 software that is slightly flexible. Other people may find it useful, other people may not. I'm building it all out in the open anyway. Hopefully other people can at least learn from it. But this is largely just driven by my own personal curiosity and desire to build something cool for a weird platform. Okay. Let's get a new page up. Again, I've said this a few times already, but this is a new microphone stand. Please let me know how my audio quality is, if anything needs to change. Let's talk about acceleration. Okay, how do we get from here to here, right? So we're going to have an analog stick that's going to move in a certain direction, and we measure this direction. So what we really want is to modify the current velocity according to this direction, right? We want to add something to this velocity based on this direction. And that's pretty much it, right? If we've got the analog stick, okay, we've got our little analog stick. If it's pushed to the left and our current player is moving over here, we want a force to act on our player that drags it over in this direction, right? That is slowly going to rotate this vector around and kind of, you know, drag our momentum around to eventually where we're holding the analog stick, right? Bit by bit. So how do we do that? Well, we've kind of got the right idea here, I guess, but in the wrong way. So we have momentum, okay? Momentum's cool, but now we need to, rather than just overriding the velocity, we need to modify the velocity. We need to mutate the velocity. So let's turn add direction into something else. Let's say direction scale. Now, here's an interesting problem. We're going to have some kind of, acceleration coefficient here. Do we multiply the acceleration by the delta time, or do we blindly apply that to the speed and then multiply the velocity, rather, by delta time before we apply it to the position? I think we need to multiply the velocity by delta time. We may also choose to multiply acceleration by delta time, but then you kind of get this delta time squared. I'm not 100% sure. I'm going to multiply everything by delta time. I think that makes more sense. So let's accelerate by 5.8 pixels per second. I think that'll end up being a lot because this compounds very, very quickly. And then we just say self velocity add dir, right? That's it. This is actually less logic than we had before. And then we just add the velocity. So what happens now if I do this? Okay, let's make scripts. And let's hit the select button. Our velocity freezes up. That's okay. We have made a typo. We've done this velocity again. I don't know what this word is. I've never heard this word before. I don't know why it's in my brain. Scripts. Okay. But this is cool, right? So we've got this engine spewing out, and I can hit select, and we've now resolved it. And I can now move. And we're going to accelerate very quickly because, and this is what we want to see, right? This is acceleration. This is raw power, okay? This is amazing. Look at this guy go. But the problem is, because we have no upper bound, we're just going to fly across the screen here, right? And then if we want to slow down, we've really got to pull back on this. We've really got to commit, right? So this is cool. Acceleration is cool, but acceleration brings up another problem, which is we need some kind of maximum bound on the speed. Refraction says your pilot's drunk. Exactly, right? This guy is out of control. He needs a DUI. So This acceleration coefficient may even be a bit high. Let's bring it down to like 3.2, okay? And then we're going to say, we add the velocity, and then if velocity, I'm apparently having trouble spelling that word tonight, if the length is greater than some maximum speed. So how fast do we want to go? Maybe, let's pick a number, let's say 80 pixels per second. Then, so if our speed has exceeded some limit, we need a way to set the length of a vector. I don't think we currently have that. If I go into like vec2, vec2.lua, I can scale. So if our length is greater than 80, okay, and then we take, let's say, I'm just gonna do some math real quick here, okay? I can't explain it. I can't explain it. We're gonna divide 80 by. We're gonna divide 80 by the length, and that's gonna give us a number that is less than 1. And then we're gonna say self velocity scale c, right? Because you cancel the thing. And you cancel the thing, and then you just have 80. Okay? That's maths. That's how maths works. Make scripts. Isn't this a much nicer way to work than before, though? We would have to, like, tear everything down all the time. And now it looks like we're gonna have a max speed, maybe? Okay, maybe the max speed didn't work. Guys, I don't think the max speed worked. Oh dear. Okay, hold on. Length is greater than. Let's go log debug scaling back. Let's do this. Let's see if we can script. Let's see if we can at least log the issue. Okay, well that stopped us dead. At what point do we exceed? Oh, hold on. I realize what's happened. We're not going at 80 pixels per second. We're going at 80. We're going at 80 30 times, or 60, 30, 60, some number of times per second. Okay, this number is much higher than 80. So we do have an upper limit. It's just way too big. So let's just set this back to like, let's go back to like 8. Okay, let's go back to a very small number. We make scripts. I really need to set that up to happen every time I save a file. Okay, let's see what happens now. That looks a lot nicer. I don't think I have debug logging on, but it looks like we hit a maximum speed here where we accelerate no further. Okay, but then we can turn it around. Ooh, this is silky smooth. Okay, this is silky smooth. This is maybe even still a bit too fast, right? I think we need slightly higher acceleration and slightly lower max speed. But the important thing is that this base logic works, because now we're going to come in, we're going to start changing player state. And so this is where the reloading actually doesn't work. Reloading maintains all of this state. So when we come in here and we add a new field that says max velocity, and we're going to set it to something like, we're going to set it to something like 8, I guess. Let's keep it at about, let's keep it at 7.3. And then we're going to have a new field called acceleration. And acceleration is going to be, I need to double check what the current acceleration is. What magic number have I used? 3.2. Let's make the acceleration 4. Okay? So these seem like pretty reasonable numbers. This max velocity, not in pixels per second. Almost every, this is in pixels per second. This is not in pixels per second. Velocity itself is not in pixels per second. So this is actually, we're kind of mixing units in a weird way here. It'll be okay. I'll be able to sleep tonight, but it's just a little odd. So let's come in here, let's go self.excel, and let's go self.max velocity, self.max velocity. Cool. And this works. So if I go make script. Oh my gosh. It's very cold here in Melbourne tonight. My fingers are getting clammy. Okay, so let's hit select and let's see what happens. And yeah, it looks like something happened, right? So let's add some rocks back in and see how we go, see how it feels to move around, you know, if we can kind of stay out of danger's way. Let's go game. And we're going to have to restart here. So we'll go make run. And this was, when I was playing around with this on the PS2, it was very cool, right? Because I could change things around, you know, very quickly. I didn't have to go through the arduous process of actually restarting the console. So this is going to be a big win for when I'm actually, you know, iterating on real hardware. That's going to be incredible. It's going to be huge. Nice. Okay, this is a bit too fast, right? You can kind of tell. This is a bit too zippy. He's a bit too keen. So let's bring our speed down. Let's bring our speed down. And because if you think about it, right, one here, right, a max speed of 1, that would actually be a max speed of 60 pixels per second. So let's go to like 1.4. Let's go to 1.4. And let's make run again. Let's see if we get a slightly more sensible player. This is still quite fast. This is still quite fast. Because I didn't make scripts, I don't think. Oh wait, no, hold on. I'm in the wrong version of this file. I'm in the engine version of this file, not in the actual like editor version of this file. Where are we? Script entity. God, it's confusing. Script entity player. Okay, there we go. Thankfully, I didn't lose anything here. Let's just go to 1.4. That happened a few times off camera where I lost work because I was editing the wrong file. That was the infancy of the reloading. Okay, now we're going a sensible speed. This is too slow. This is too slow. This... Oh my god. Deadly monitor arm. Reach Adrian, thank you very much for the follow. Hope you're enjoying the PlayStation 2 Madhouse. Okay, so max velocity needs to be higher than 1.4. Let's try 2.2. We're going to very quickly cross the threshold where this gets into insane territory again, okay? But we're going to see how we get there. Oh, that's okay. That's quite nice. That's kind of like a sensible Sunday flight. It's not quite extreme enough. It's not quite radical enough for this to be, you know, fun, right? I think it would feel... cumbersome. I think it would feel tedious if this was the max speed. Okay. Let's try one more thing. Let's try not 23. That would be insanity. Let's try 3. Let's see what we get out of 3. Okay? 3's a magic number. 3's a lucky number. That's okay. Again, I don't know. I kind of like going fast, right? I kind of feel like being able to go extremely fast is kind of fun, but also having a sensible upper limit is probably not too bad. I like this for now. This feels good for now, right? You can't just get wherever you want very quickly. There's a bit of give and take with the acceleration. You're not fighting it too much. You know, this is cool. This is cute. This feels like a game. This feels like an actual game you could play, right? There's something kind of a bit addicting about it already, right? It's very simple. It's very simple. Cool. So that feels like player momentum is done. Ready to ship, right? No bugs. 0 bugs. Everything works first time. Perfect. I did promise one other thing in my roadmap though, right? So I did say friction. And playing around with it now, I actually don't think friction's the right way to go. I think we want our player to slide forever, okay? Because when I took physics in year 9 in high school, they told me that I could imagine the spaceship was a perfect sphere in a vacuum. So that's what I'm going to do. Right? Perfect frictionless vacuum. That's how I learned to do physics in high school. So that's what we're going to do here today. So we do have this other problem, alright? And that problem is that the game slows down because the game manager tries to just spawn rocks forever. Okay. Infinity rocks is bad. So let's come into the game manager and let's have a look, right? So game manager has this timer called next rock, which keeps track of when it should spawn the next rock. If next rock is less than 0, then, you know, set the next rock to some timeout. We should probably make this an option. Right, let's go next rock delay maybe. And then you accumulate a thing. Sure. Here we go. Depends on which is more fun. Sometimes you have to forgo physics. You made a game where you couldn't change direction while jumping and everyone hated it. But when was the last time I changed midair? Yeah, no. And jump physics is especially, like, controversial, right? I think for an Asteroids clone, people can get their head around never stopping. I think that's actually kind of the default for Asteroids games, but I don't remember the last time I played one properly. I do love the, like, commit to your jump, though. I'm trying to think of a good example. Other than, like, cinematic platformers like Abe's Odyssey, right? A good example of games that really commit to that idea. They're out there. They're out there. Okay, so I can't actually remember what ACK does in this case. Other than just count. Oh, no, you know what ACK does? ACK counts the total number of rocks spawned. So the idea is that, you know, as we spawn more rocks, maybe we interpolate this delay down to some smaller delay, right? So we say we've spawned 100 rocks, make the delay shorter. Make the game a bit more fast-paced, a bit more intense. You know, maybe spawn something other than a rock. Maybe spawn some kind of adversarial enemy or some kind of bonus or, you know, something. But that can all be tied to this accumulator. So for now, the accumulator just counts. That's okay. And I was very happy with this logic. Very, very happy with this logic. So, make a rock. But what we really want to say is, if next rock is 0, and self.rock spawn count less than dot rock spawn max. So if you know, we're going to count how many rock spawned count equals 0, rock spawn max. So we're going to count how many rocks we've spawned. We're going to cap it at some sensible number like 8, I guess. Okay. Less than this. So if we run this right now, this will not complain, this will not crash, nothing will go wrong, and it will just happily spawn rocks forever, right? So we need to come in, we need to say, okay, well, when we spawn a rock, we're going to say, let's, instead of spawning it here, let's go rock equals self make rock XY. I mean, actually, probably just say, this, right? You know, pull this inner thing that really has no need to be here out. We're just setting these two numbers. Make a rock at XY and then say self rock spawned count equals self rock spawned count plus 1. Okay, so now we should spawn 8 rocks and then stop. That is going forever. That is getting silly. Okay, so here we see 1 rock. 1 rock. We see 2 rocks. I should have set this to a lower number. 3 rocks. 4 rocks. 5 rocks. I think 6 rocks. 7 rocks. Maybe 8 rocks. I think that's 8. 1, 2, 3, 4, 5, 6. They're very hard to count, but it looks like we've capped out at some number here. Looks like we've capped out. That's good. That's good news for us. Okay, that's very good news for us. So now we just need some way of saying, well, hey, when this rock gets destroyed, de-increment this counter. So if we come over to the player bullet, okay, the player bullet, a very important entity. Social signal. Okay, because this has this signal function, okay? And this signal function updates something back. When it collides with something, it can kind of modify. When the AABB collides with something, it can send a message back up, right? It can send a message back up. I guess the other thing to think about, rock.lure on collide. The rock also does not have an onDestroy method. It does have an onDestroy method. I already thought about this. The onDestroy method has a callback. If there is a callback defined, then call a function called CB on this entity. So what this means is, in our game manager, if we go, so let's go local rock equals self make rock xy. Oh, hold on, we're already using the callback. I take it back. Okay. Self make rock, okay? Self dot rock spawned count equals self rock spawned count -1. I already thought this all through. I already did this. I don't know why I'm overcomplicating it for myself, right? We just reduce the rock spawned count by 1. Now let's come in and let's say that we can only have 2 rocks, because 2 is a nice easy number to count, okay? We're not going to have any problems counting to 2. I promise. We're going to run this, and we're going to see what happens. We're going to see rock number 1, okay? We're going to see rock number 2, and we're going to see no more rocks. Just 2 rocks. Just 2 rocks, okay? Just 2 rocks hanging out. We're going to shoot 1 rock, okay? And then a second rock appears. We're going to shoot 1 rock and a second rock appears. Isn't this cool? This is a game, right? As quickly as we shoot this first rock, a second rock appears, and that's actually kind of shit. That's actually kind of a shit experience, but we're going to keep it for now, because I think this is going to keep the game feeling quite chaotic. Wow, really, just as soon as you shoot it, another rock comes in. And if you think about it, that makes sense. If you think about the logic that we're dealing with here, right? What this logic says is, well, if we're due to spawn another rock, and there is room to spawn a rock, then spawn a rock, okay? But if there isn't room to spawn a rock, it's still time to spawn a rock. It's always time to spawn a rock. So the instant that we de-increment this counter, the next rock timer is going to, the next frame we're going to spawn this rock. So how about this? Every time we destroy a rock, let's say self.nextRock equals self.nextRock plus 0.1. We're going to add 1/10 of a second to our next rock spawn counter every time we destroy a rock. A old rock, a new rock, it doesn't matter. 1/10 of a second every time we do it, right? Oh my gosh, I'm very, very bad at my own game, evidently. Okay, so I come in, I shoot this rock. They still come out quite quickly. That actually made no appreciable difference to the rate at which a rock comes out. Okay, well that's odd. But that's kind of cool. We can roll with that. Let's actually just get rid of that logic altogether, okay? Rocks are just going to come out. They're just going to move quickly. It's going to be hectic. There's going to be a lot going on. We're going to go back to 8 rocks. We're going to run this, and you're not even going to notice that there's a cap, okay? This is going to be kind of magical. So we're going to let this run for a second. We're going to build up. We're going to accumulate some rocks. Okay, so we're going to move around, we're going to shoot, right? It feels like we have some slowdown with 8, so we might have to lower this to 7, but look at this, right? We're going to see if we can get this down to nothing, right? We're going to see, we're going to see if we can thin the pack a little, right? If I can learn to shoot, that would be cool. Wow, I really have terrible aim here. But you can see, right? I don't think it's noticeable that there are new rocks spawning as quickly as old ones come in. I think this is okay. I think my rock spawning algorithm is very, very good as well. Not to toot my own horn, right? But they kind of move through the center. They feel like they're engaging rocks to shoot. They're not all obviously going directly through the center. There's a bit of variance. There's enough variance, but they also feel very focused. But then they also drift away from the center the longer they survive, right? So, if you kind of focus in towards the center and shoot all the rocks as they spawn, you're going to have kind of an easier time, I guess. Except then you get ones like that just kind of go off to nowhere. Okay, so we can get it down to like 3, but I think it would be impossible to actually clear entirely the field. But yeah, this is why you need some kind of counter, right? Okay, maybe you can clear the field. This is why you need some kind of counter that says, okay, the more rocks we spawn, the more rocks we should spawn. And then we need something else. We need some other kind of entity that can engage the player's brain a little bit more than just a dumb rock that moves around, right? But this is a good start. This is a beautiful start. I love this. I love this a lot. Let's commit it. Let's call this game manager rock limit. Cool. Cool. So let's push this bad boy. I can't believe I remember that. I haven't typed that in for like 2 weeks. And I'll merge that after the show. Okay, so let's head into our PS2 homebrew engine. Fix font. Weird. I don't actually have any... Okay, I don't actually have any differences here. Let's git check out main. Okay, so there's a problem when we run that. And I probably should have highlighted it, right? But when sprites overlap, things go wrong. And I spent a bit of time trying to fix this recently. I have a little bit of time now, so let's at least make a start on this before I call it for the day. Let's make at least a little bit of a start on this, okay? So if we look at the source, at our draw 2D logic, we don't do anything with it here. What's it called? Alpha. If we look at buffer.c, right? We set the alpha, and we have this GIF tag format that sets the alpha, right? This alpha register is really interesting. It lets you basically set up how the blending is going to work. And the formula is as follows. Let me just quickly pull up the GS manual. And look at this. I've got it right here. So let's go. Let's go to page 2. Okay. This is going to be very, very different. We'll put a little squiggly line so it's different. CV equals. I did a bit of this before, right? A minus B C left shift 7 for whatever reason plus D. Okay. And so you can set these up to be source destination, some specific alpha stuff, and blah blah blah. So we can rewrite this a couple of different ways, right? We could say this is source minus destination times, let's say, alpha source plus destination, I think, right? Which is also kind of like, hold on, there's a way to rearrange this. My brain's doing a thing, so it's AS minus DS plus D. Hold on. AS minus AD plus D, right? So it's S minus... There's a thing. There's a rearrangement of this that like makes a lot of sense and makes it look like alpha blending functions you've seen before. But this conceptually is not too odd, right? So we've got the difference between the foreground and the background. We multiply that by the alpha, and then we add on the background back. This should give us sensible transparency, and this is what it should be set to by default. And for some reason, we do not get the thing that I expect to have. So there's a hack. And that hack is for drawing sprites that have no transparency, like our sprites. Well, no, like, partial transparency. You just draw source, right? You set A to the source, you set B to 0, you set C to 0, and you set D to 0. You just draw the source. Or you set A to 0, B to 0, C to 0, and you just set D to the source, right? that is a solution. So if we make this programmable, if we make this configurable, if we make sure that for every primitive we draw, we could actually set this individually, if we make this part of our draw 2D state, right? So if we come up here, and we're probably going to accumulate a few other weird things like this, or rather draw.h. And the more weird state we accumulate in draw 2D, the harder it will be to come back in and retroactively make this work well for 3D. But this alpha stuff, there are actually good reasons why we might want to change it mid-frame. So we're going to add in an override for it, okay? We're going to make it fixed though. We're not, or are we? Do we make it fully programmable, or do we just say make do? Let's make it fully programmable for now. Okay, let's go char alpha mode. It's going to take in 4 things. Now we're going to come in and we really need to know like if it's changed, because it's not going to change all the time. We don't want to be setting this all the time. So what we really need, right? So we've got our state, right? So we've got, let's draw another line so we know this is different. We've got D, our draw state. And this has things like the current GIF tag, right? Things like the current texture that we're drawing, the current DMA tag that we're building, you know, all of this important state. And when we actually need to draw, say, a sprite, we refer to all of these things to build the raw GPU commands that then get sent off to the GIF, right? So if we were to just come in carelessly and say alpha, right, what we would end up with is every time we draw a set of these GPU commands, we would need to manually set the alpha. This is very much how this works right now, right? It just reads these things, and because so far all it does is the bare essentials, right? There's no extra fluff like manually setting alpha. It's okay. We just refer to them. We just jam everything into this buffer and send it off. Not quite that simplistic, but this is the kind of rough idea, right? There is a little bit more logic to try and avoid duplication. Some of it actually doesn't work properly, and so there is just all the duplication right now. But if we come in and add something like alpha, which is probably going to change infrequently, it would be wasteful to set this in every single primitive that we kick off to the graphic synthesizer. So maybe we need to define some kind of set, right? So let's say alpha, let's say no, not texo. There's a few of these registers, right? Let's clamp mode, right? Dithering maybe, alpha correction probably not. Fog. Things that we might change once or twice in a frame, but not all the time, right? So let's just say fog. Fog will cover fog and the fog color. MIP mapping maybe. Yeah, let's go for that, right? So let's say we have these auxiliary things that can make our drawing more pretty and more beautiful, but we're not going to set them all the time, right? So let's say we have this set. Let's combine this with a dirty flag. Anytime we change any of these, the dirty flag gets set to true. Then the next primitive that we draw has to include the information to set this collection of vanity registers, right? So let's call it this is a terrible name, right? But when alpha changes, we have to include it in the next thing that we draw. So we're going to say, when we set the alpha mode, we take in A, B, C, D. And we can put a higher level wrapper around this, right? We can have a mode that's A equals 1, B equals 2, C equals 0, D equals 0, right? We can define these as an abstraction on top of this, but this is just going to be a raw function that sets this mode. We're going to go draw2d.c. We can come in, we can say, okay, set alpha mode, state dot alpha alpha 0 equals A. B, C, D, and then state.vanity dirty equals 1. Cool. Okay. So now we need to come in and every single thing that we do here, right? Every time that we start a new gift tag, we need to say, well, every time we start a new gift tag where we draw something, we need to say if state vanity dirty, then state.vanity dirty false gift tag ad gift tag ad alpha right? So we fix it to something. So we can now store this in our state, we can now program it, we can now mess around with it in the running program, which is going to be nice, right? We can use our hot reloading here. And this is a pattern that's going to be powerful. So I need to go through, I need to copy this up through all of my drawing methods, which is going to take a little bit. And then I need to test it to make sure it works. And then I need to go in and also make this change in my Lua renderer. It doesn't need to be as thorough. My Lua renderer can be more wasteful, but I need to make sure that, you know, these stateful changes actually occur in Lua. And I'm going to do that off camera because that's kind of boring. I'm going to call the stream there. I'm pretty tired. I worked today. I worked hard today. A few notes from refraction as well here. So right shift by 7 is to bring the result back to a normal range. Post multiplication. Yeah. Alpha range on the PS2 is 0 to 2 rather than 0 to 1. This is... hold on. So can I just quickly come back to this, right? Why is the alpha range bigger on the PlayStation 2? Because I think this is why I've got this kind of like super color appearing, right? Because when I have things overlay each other in the middle, like the overlap turns into a funky color. Maybe I'll just try and catch you another stream refraction. I feel like I should actually go over this now with an example because you'll probably know instantly what the problem is. Let me pull it up. I'm zigzagging all over the place, right? Let me pull up a good example of this. Refraction says he doesn't know why they decided on this. Yeah, it's probably just like a cost thing, right? They worked out it was cheaper to do it that way. Okay, so why do I get this funky color, right? What's happening? Do you have any thoughts on why overlapping sprites do this? They have a yeah. I'm pretty sure I don't have highlight on, right? So if I look, Cull clamp. Ooh, I haven't thought about this. 46. I never set this explicitly, right? So let me go log level. Let's find where my initial setup's done, because that's PCSX2 code. No, that's PS2 SDK code rather, sorry. Okay, so if I come up here, looking for the gift tag, the 80 register set. I don't think it's ever set. Yeah, it's never set. Okay. Yeah. Wraps around. I'll play with that. Thank you. I hadn't really thought about that register before. But I am going to cut it there. I am very tired and I'm going to stop being able to make coherent sentences soon. So thank you very much for that input, Refraction. Thank you very much everyone who's tuned in. We had quite a few viewers stop in, which was nice to see. Everyone hanging around, we're going to throw the love on and raid someone else. Before that, goodbye to all the watchers on YouTube. I will catch you next time.